All right, let's start talking about the bell work. So I want to figure out first, what formula are we going to use for each of these parts for A, B, and C? On number 1, what formula should we use? A equals P, and then what? Parentheses. To the power of NT, yes. We can absolutely use that one here. There actually is another option for this one, and I will talk about what that is as we go through the problem and see what happens. All right. So let's figure out what to substitute in for each of these pieces. For part A, what would I put in for the capital P? 3,000. That is the principal. That is the starting amount. So I would have A equals 3,000. Parentheses 1 plus, what would I put up on top of the fraction? The rate. What is our rate here? 0.06. We've got 6%. We're going to divide that by 100%. That makes my percent sign cancel out. So we get 0.06. That's what we're going to use for R. So 0.06. What would I put on the bottom of the fraction? The n value. How do I find the n value? What do I look for the n value? Annually, yes. We look for an ly word to know what to use for n. N is equal to 1. So I have a 1 down here. Where else do I put that n value? In the exponent. So 1 times what? One times what? 1 times 5. Why times 5? Because it's the years. All right. Question. What happens if you do 0.06 divided by 1? What happens if you do that fraction, 0.06 divided by 1? It's going to be the same. It's just going to be 0.06. All right, so I'm going to write down what we're saying here. Leaving everything else the same. I would have 1 plus 0.06. What happens when I do the exponent 1 times 5? What is 1 times 5? That's just 5. So I can use this formula here, or we could use this formula only when n is 1. Because it's the exact same thing. If I divide by 1, nothing changes. If I multiply by 1, nothing changes. What do you get when you pop this one in your calculator? 4,014. And what for the cents? 68 cents, yes. For part B, can I use either one of those formulas, or do I have to pick only one of them? I can use the first one. I can use the top one. Can I use this one? No, why not? It's not why. When n is 1, I can use this one. Is our n value 1 on part B? What is our n value for monthly? 12. So the formula that I have to use here is A equals P times 1 plus R over N to the power of NT. We use this one. We have to use this one when N does not equal 1. Does anything other than the N value change on part B? No. I have A equals 3,000 times 1 plus, my rate stays exactly the same, 0.06. The N value is now 12. And I have 12 times what? Twelve times 5. Guys, come up and grab a calculator if you need one. Yep, you can take the whole thing back. That's fine. What do we get when we stick this one in the calculator?
4,299.
I got 4,000, but I did not get 299.
Oh wait, that's never mind.
$4,000 what? Guys, I need the phones put away, and I need you practicing putting this in the calculator with me. Because problems like this on the test are going to be worth like 2 points. One for showing me that you've set it up correctly, and one for putting it in the calculator correctly and getting the correct final answer. If you set it up correctly, you get one of those points. Awesome. But if you don't know how to put it in the calculator, you only end up with half the credit on a problem like this.
What you said continuously is every day?
We're not doing continuously.
Monthly?
We're doing monthly right now. 4,000 what?
46.55.
4,046.55 is what an 18? Yep, 12 for monthly. How many times in a year does something happen if it happens continuously?
Like it goes every day.
How many times in a year would it happen if it happens every day? 365. Is continuously more often than that?
Yes.
Yes. So how many times in a year does it happen if it's happening continuously? More than 365. Does it happen every hour? Happens more often than every hour. It's continuously. It's just happening over and over and over and over and over and over. This is when we use E, because I don't have a number for continuously. Whenever you see continuously, this means to use E. Save it for D-Lunch, please. What's the formula that I use if it says continuously and I have to use E? A equals PE, not N. Exponent. What goes in my exponent?
The number?
RNT?
R times.
R times T. Remember, when it says continuously, we do not have a value for N. We use E for that continuously part. So I have A equals, what would come after my A value? 3,000. That did not change anywhere in this problem. And then E, exponent is 0.06 times what? Times 5 for 5 years. What do we get when we substitute this one in?
Come on, here you go.
Oh,
I got 256.
256?
I got 4,400. I mean 4,049.57.
I'm doing number 10.
4,049, and what was your change?
57.
57, 58. I would take either one, 57 cents or 58 cents. All right. Which one happens more often in a year, annually or monthly?
Annually.
Monthly. Annually means it happens how many times in a year? Once. Monthly means it happens how many times in a year? 12. So monthly happens more often in a year than annually. What do you notice about the ending balance in the account when you compound it more often? Did it get bigger or get smaller?
Bigger.
Bigger. The more times you compound it, monthly is more than annually, the balance went up, 414 to 446. Nope. One says 414, one says 446. How often is continuously again? E. It's faster than every minute, it's faster than every second, it's faster than every millisecond. What happened to the balance when everything else stayed the same? What happened to the balance when we compounded continuously but everything else stayed the same?
Did it go up?
It went up. The more times it's compounded in a year, if everything else stays the same about the situation, the higher the balance is. All right, let's look at number 2. What does it mean for something to be to the 5th power? Times itself 5 times. So this is 4 m to the 4th, n to the 5th, times another 4 m to the 4th, n to the 5th. Do this 5 times. There's 3. There's 4. We multiply it by itself 5 times. So when I'm looking at this, how many times have we multiplied 4 to itself? 5 times. 1, 2, 3, 4, 5. What's another way that I can represent that idea? 4 to the 5th power. What is 4 to the 5th power? Try again. 1,024. How many times are we multiplying m to the 4th by itself?
4.
There's 1,
Oh.
2. How many times? 5, 3, 4, 5. I have 5 m to the 4th that are all being multiplied together. M to the 4th times itself 5 times. What do I do in a situation like this where I've got an exponent on the inside and on the outside of parentheses? We multiply those. So this would be m to what power? M to the 20th. What about the n to the 5ths? How many times? Yep. 1, 2, 3, 4, 5. I have n to the 5th being multiplied by itself 5 times. So I'm going to multiply these exponents together, and that gives me n to the 25th power. So that would be my final answer on number 2. That would be an equivalent way of expressing the exact same idea. It has the same value as what we had originally, but it's written in a way that looks different. But we have the exact same value here. Do you guys have any questions for me about the bell work?
Does it matter what order you put the M and N?
The M and the N, no, that does not matter. So if you put the N first and then the M, that's fine. Typically in math, when we have more than one variable, we go in alphabetical order. But if you mix up the order on those, it's not necessarily wrong. Yes, sir?
No, it's not with this, I just need a packet.
Oh, yep, I can get you another review.
I'm not trying to like take pictures.
Oh, goodness. Oh, good catch. All right. So I want to take a look at your review packet. Go ahead and pull that out for me, guys. Stapled packet that I passed out yesterday. If you do not have one, please raise your hand. I'm happy to give you another one. On the test, you will get the exact same formulas that are up on top of your review. Whenever you see a story problem, we're going to be using one of these for our story problems. How would you know when to use the one that has the N's in it?
If it has
If it has annually,
annually,
if it has
monthly.
monthly, weekly. So there's another keyword that you'll always see here. So it would say compounded, followed by an ly word. So if you see the word compounded, and then there's an ly word, annually, monthly, weekly, daily, quarterly, you're going to use this formula right here. What keyword would you have to see in order to use this last one, the one that has E in it? Continuously. So when would we use this one? This one right here. When it says neither of those. So no compounded. Or you could use it when n equals 1. You can use this one or the fourth one over when n is 1. All right. Let's look at number 1. Number 1, we're supposed to describe whether this is showing me exponential decay or exponential growth. How would I know if it was decay? Less than 1, when your base is between 0 and 1. Or negative exponent. When would we know it's showing us growth? Yes, when your base is bigger than 1 and it has a positive exponent. How do I know when I'm looking at a problem where the base is?
If the base
Has an exponent on it. The base has to have an exponent on it. So on number 1, part A, what is our base? 10 over 8. This is the base right here. Pop that in your calculator. Let's do 10 divided by 8 in your calculator. What is 10 divided by 8?
1.25.
1.25. Is the exponent positive or negative? Positive. So is this growth or is this decay? This is growth. What's the base on part B? What is the base on part B? 0.75. Tell me about the exponent. Is it positive or is it negative? Positive. Third table back where there's only one student sitting. It's less than 1. So is this growth or is this decay? This is decay. Last one, part C. What's my base? 3.5. Is the exponent positive or negative? Positive. So is this growth or is this decay? Growth. Number 2. Is that a story problem? Yes. Which means I'm going to have to use one of the formulas, like starting at the halfway point and going over. Read through that story problem carefully and tell me which one of those formulas I'm going to need to use. Which one? A equals P, parentheses 1, plus or minus R to the T. Yep. How do you know that's the one that you have to use? It doesn't say compounded, and it doesn't say what else? Doesn't say continuously. If you don't see compounded, you don't see continuously, this is the one that we're going to use. What does this symbol here mean? It could be plus or minus. We have to decide whether it's plus or minus. You won't use both, the plus or the minus. Table back on the blackboard side where Emma sat earlier. In this problem, are we going to use the plus or the minus? What do you think? Would I use the plus or the minus here? Minus. Why? Because it says decreases. So we will use subtraction. It says here that we're going to write a function rule. What did I tell you guys the other day? And I've told you more than once. When we write a function rule, how many letters, how many variables do I need? 2. Which 2? Yes, we will leave A and T as variables, as letters. So I'm going to have A equals, what should I put in for the P value? 25,000. Why? It says it is the initial cost. This is how much it's worth when they buy that car. So 25,000. And then I have 1, and I have to choose between a plus or a minus here. You cannot do this. If you put a plus minus here, I will count it wrong. You have to make a choice. Are we using plus or are we using minus? Minus. What would I put after the minus?
0.15.
0.15. We take this 15% right here. We divide it by 100%. That makes my percent signs cancel out. We get 0.15. There's our value for R. And what else do I still need here? The time. What do I put in for the time? T. Whenever we write a function rule, we have to have A still as a letter and T still as a letter. You're not going to plug anything in for T for a function rule. Do they ask us to do anything else on this problem? Then we're done. That's all we need to do. All right. Let's look down at number 3. There's a whole bunch of stuff going on in number 3. There are 2 different graphs here. I'm going to trace over them with different colors so that they're a little bit easier to see. There's this graph right here. That's Q of x, and they give us the equation for Q of x. And then there's this graph right here. And that's G of x. When you look at these 2 graphs, how would you describe the transformation? What happened to Q of x to get G of x? What happened to Q of x in order to get G of x? It did not move to the right. It reflected. Reflected over what? Reflected over the y-axis. X-axis goes left and right, but when you reflect over the x-axis, you would flip it over that back and forth line. When you reflect over the y-axis, you would flip it this way. Which one of these graphs is going up from left to right? Not both of them. Which one starts low and then goes up as you move further to the right? Q or G? Q. This one starts low and goes high. So would that be growth or decay if it starts off low and then goes up high? This is growth. So what about G of x? What about the red one? Would that be growth or would that be decay? Decay. Why? Because what? Starts high, goes low. Pick that up, please.
You need that.
This is decay. Is that any of the questions on here?
No.
Read through all the questions carefully.
Equations.
So far we just have words, right?
Yeah, you need to write accepted equations.
We will. That's part A. We said part B, describe the transformation. It's reflected over the y-axis. Do I need to know about growth or decay for any of these questions?
It goes up, starts up. 1.
Which question? A, B, C, or D?
Describe the transformation.
We already described it. That's a reflection over y. We'll get there in a minute. Read all the questions. Which one of these is asking me about growth or decay? D. Which graph, Q or G, is an example of exponential decay? Which one is an example of decay? Which one starts high and then goes low? G of x. Because it starts high and then goes low. It's losing value. That's why you see it going down. There's an invisible line that neither one of these graphs is crossing. Do you see where it's flattening out on the graph? Right here. Technically never touches, never crosses, right? Where is that at? 0. But I always write a horizontal asymptote with what? I can't just write a number there. Y equals. So y equals 0. Y equals 0. Neither of these are crossing that line. Horizontal asymptotes are always y equals. Is it always 0? It's always y equals k. Always y equals k. All right, let's go back and do the function rules. There are 2 different ways to write the function rule for g of x. Do we know what the base is for q of x? Yes, I did. Do we know what the base is for q of x? Base is 10. Right here. Up on number 1, we said that there were 2 different ways that I could know something is decay. What are the 2 different ways that something could be decay, exponential decay? If what's negative? The exponent. So to get that reflection over the y-axis, same base, but with a negative exponent. That'll take it and just flip it over the y-axis. The number absolutely cannot be a negative. The base is never allowed to be a negative number. What does a negative exponent do to the base? Turns it into a fraction. So the other way that we could write the exact same equation for this graph, 2 different ways of writing that function rule. I can do 10 to the negative x, so same base, but to a negative power, that'll make it decay, or 1 over that base to the power of x. Hmm?
No, I was part B when you said reflective axis. I didn't really get into it.
It's reflecting over the y-axis. Reflecting over x would mean a negative a value. Reflecting over y is when it goes from growth to decay. So it flips over this way. So instead of starting low and going high, it starts high and goes low, but it's not upside down. Does that make sense?
Yeah.
Okay. Do you guys have any questions for me on this one? Cool. Let's look at number 4. What does number 4 want me to do?
I don't know.
What's it asking us to do?
Identify the following, so identify the transformation from the parent.
Identify the transformations from the parent. That's the first thing I need to do here, yes. So the parent is y equals the base to the power of x. How do I know which piece is the base? How do I know on one of these equations with transformations, whatever has an exponent on it? What has an exponent here?
4.
4. This is the base. Make yourself a big note on the bottom of the page. The base is not A, H, or K. So it does not affect my transformations. The parent would be y equals 4 to the x. If 4 is the base, then what's my a value? If 4 is the base, what's the a value? It's 1. The a value is always found in front of the base, right here. If you multiply something by 1, does it get bigger? Does it get smaller?
No.
It stays the same. So does this a value cause a stretch or a compression? No, it's exactly like my parent, which means I do not describe that as a transformation because it's not different from the parent. Do we have an h value here? Yes, what is the h value? 5. Remember, this right here always has the opposite sign. So that means h is 5. What would that do to my graph? Because that is different from the parent. Goes right 5. Do we have a k value here? What is our k value? 3. Will that affect my graph? What will it do to it? Up 3. What else does the k value tell me? There's something else up here that the k value is going to tell me. The horizontal asymptote. What do I have to start a horizontal asymptote with? Y equals. So this is going to be y equals what? 3. It's always y equals k. What is the domain for all of my exponential functions? It doesn't matter what the base is. All real numbers. So negative infinity to positive infinity. Or you can write that with that weird R symbol.
R is.
Right. You with me, Dwayne? Eyes up here, sir. The range. It's going to be one of two different things depending on what that graph looks like. If the graph looks like this, the range will be k to infinity. But if my graph looks like this, the range will be negative infinity to k. How do I decide whether it looks like the top one or whether it looks like the bottom one if I can't see it. A value. Up here is if A is positive. Down here is if A is negative. Did we say our A value was positive or negative? Positive, because we said it was a positive what? Positive 1. So we're going to go with this one. A is 1. So what would my range be then? 3 to positive infinity. Here's my K. Flip this over on the back side. Yes, ma'am. Flipping this over on the back side. What do I need in order to do problems like these? Yes. The bases must match. What are the bases on part A? 4 and 64. Which one of those do you think we should try to rewrite? 64. 64 is the same as what?
4 to the 16th power.
No. 4 to the third power. Yep. It's 4 times 16, which would be 4 times 4 times 4. So this is 4 to the third power. So that's just rewriting the 64. What do I do with this exponent up here? Yep. We're going to bring it down here. And that means we're going to multiply these pieces together here. On the other side of the equal sign, I'm just going to bring everything down. 4 to the 3x minus 3. Do these bases match now? Yes. Why did I want those bases to match? Yes, that means my exponents are now equal. What's the exponent on the left? 3x minus 3. On the right, I have two exponents. We have the 3 that's on the inside of the parentheses, and we have the 2x that's on the outside of the parentheses. We have to multiply those together. So I have 3x minus 3 equals 6x. What's the goal of the problem? To solve for x. Where is x? On both sides. I need to make one of them cancel. How do I make one of them cancel? Subtraction. Which one should we subtract? Thank you, sir. Let's subtract 3x from both sides. So over on the left, I have a negative 3 left. What is 6x minus 3x? 3x. How do I solve it from here? How do I decide whether I divide by positive 3 or negative 3? Yes, whatever's next to the x, that's what I need to divide by. So we're going to divide by positive 3. We get negative 1 equals x. Let's do part B and we'll wrap it up there for today, okay? Do my bases match? No. Which one do you think we should rewrite? 125. 125 is the same as what? 5 to the third power. And then I'm going to bring down the rest of this exponent over here. 2x plus 4. Other side of the equal sign, I'm just going to bring straight down 5 to the power of 3x. Do the bases match now? Yes. So what do I do with the exponents then? If the bases match, what's true about my exponents? They also match. They are equal. So over here I have 3x. What do I have on the right side though? What do we have on the right side? 3 and 3 parentheses 2x plus 4. I have to distribute that 3 to both of the parts of that other exponent. So I have 3x equals 6x plus 12. What's the goal of the problem again? To get x by itself. Where is x right now? I got 1 here. I got 1 here. I don't want it on both sides. I want it on just one side. How do I make one of them cancel? Subtract. We're going to subtract 6x from both sides this time. What is 3x minus 6x? Negative 3x equals 12. Divide by negative 3x. Divide by negative 3. Don't put the x down there because we don't want the x to cancel. We want the negative 3 to cancel. X equals negative 4. Nice work. You guys need to finish up the other 2 problems on this page. Preferably, you'll continue working throughout that or on that review. But I will briefly go over the 2 problems on this page first thing tomorrow after the bell work, and then we'll start working on the 3rd page. Tomorrow, is there anything special happening?
No.
No. What day does have something special happening?
Friday.
Thursday. Friday too. What thing is happening that's special on Thursday? Black History Month convocation, which means all your classes are shorter, except this one.
What? You lying.
No, I'm not. Nope. 5th period stays the same amount of time because this is where the lunches are. And they can't give people less time to eat lunch. It already takes too much time to get through the line and eat anyway. Right? What is happening on Friday? Test. We should be able to get completely through the packet before your test on Friday. If you guys have any questions, I am more than happy to answer questions for you. But everything that's in the packet, you need to know how to do for your test on Friday.